Hello, and welcome to the session today on Making Complexity Simple, Building Universal CPE for the SMB segment. My name is Chris Burgy. I'm VP of Corporate Development at Ooma. I'm joined by Toby Farrand, who's the VP of Engineering, and Matt Gillon, our Chief Software Architect. A little bit of color about Ooma if you've not heard of us. Most folks, if they recognize the name, will recognize us from our long-standing heritage in the residential VoIP space. We've been at that since 2004. However, the company over the past 8 years has pivoted into the small business and the distributed enterprise segment. Today, our portfolio represents a variety of communication solutions across the small, medium to large business segment. And as a company, we enjoy over 1 million users on our core platform, 2 million if you include all of our platforms. One of the critical things for us as a company, coming at this from a heritage in the residential space, is really applying this ethos around simplicity for customers, around deploying solutions, managing solutions, and making them value-oriented or achievable from a cost perspective. We're very proud of the solutions that we've created, and we're really excited about the future in applying the same sort of methodology to a variety of other deliverables in the market. In particular, we found that small business customers are a challenging segment for many companies to design solutions for. Their needs are vastly different than other segments in the business market. They're also challenged by the fact that they don't typically have the same set of resources available to them as larger customers. So as we look at the small business space in particular, there are these unique challenges that we really keep an eye on for designing solutions, and we want to share some of the vision of what we have built or are building in the universal CPE space with you, along with some of the challenges that we faced as an organization in designing this type of flexible platform. As we started our journey in building this solution, we recognize that small business customers typically lack their own information technology resources. This means that you have to really keep an eye on how you can design solutions to be easily consumable and easily understood by this type of business owner, and they represent the vast majority of organizations in many countries around the world. What we've also found is the reliance on internet access has increased in significance over the past 5 years. Many organizations have shifted the applications that they use as a business to operate to the cloud. And we found that more and more folks are distributed in terms of their workforce than they have been in the past. And this presents a variety of different unique challenges for organizations around how they connect these types of employees, and more importantly, how they secure connectivity in a distributed scenario. Due to the size of small business customers, one of the other challenges they're faced with is consuming solutions in an affordable manner. They have to keep a close eye on complexity given that they don't have IT in their environment and they don't typically have the budgets that are associated with large organizations. And what we found as an organization is that trying to transfer a solution that's built for enterprise customers runs into a whole set of challenges for this type of customer. It's typically easier to design for an SMB customer and scale that up to meet the requirements of much larger organizations. Furthermore, as you look at the broader networking space, customers today are forced into multiple different proprietary hardware solutions in their environment, whether it ranges from routers to firewall solutions to software-defined WAN solutions. There are lots of choices, lots of complexity around deploying these types of technologies in a customer environment. And for us, as we evaluate the SMB segment and learn from our heritage in this space, we found that when you're often building solutions, it actually parallels what companies do in the consumer or residential market. That really designing an offering with that small office, home office in mind is important to make technology palatable to this type of customer. For us, we have a broad vision around business in a box, that suite of services that are really critical to a small business customer for operating their environment effectively and efficiently and with easy access for all of their employees, whether in an office or working from their home. As we set out on this journey of a universal CPE solution, for us, it was important to deliver a capable platform that allows us to address a broad array of needs in customer environments across routing, security, the ability to manage multiple different internet connections, the ability to connect wirelessly, and leveraging technologies like mobile networks, whether that be LTE or the forthcoming 5G solutions. And this same platform presents a really wonderful opportunity to think more broadly than networking solutions today. And so as we set out on this design mission, we wanted to provide the flexibility in a platform to deliver other services beyond what is traditionally thought about from a customer perspective today around key technologies to enable network access. And so we put a lot of thought into making this a flexible platform to run different types of solutions, like IoT sensors, for instance, or custom applications that may be appropriate for a larger distributed enterprise. With that, I'm going to turn it over to Toby Farrand to walk you through what we've built so far.
Thanks, Chris. So as Chris alluded to, this is a bit of a shift for Ooma. We're historically have provided voice over IP services to small business. And what we recognized was that once you have the infrastructure in place to do that, there's a lot of other applications that become possible. And for our target customer, which is quite small, a handful of users typically for any particular location, we have some unique challenges and opportunities to address that. As Chris alluded to, they don't typically have IT departments, and so the first priority for us is to make sure we can get the device installed successfully, hopefully by the entrepreneur or the small business owner, not relying on a professional install. So, for example, we do things like we have Bluetooth and near-field communications built into the device, so that the first communication that occurs with the box could be a setup app on your cell phone, so that you're not even dependent on your wideband access actually being alive for the initial phase of installation. So, from a hardware design perspective, that was one of the first priorities. The other key for us is once we get a device that's installed in one of these small businesses, the user, the person owns the business and is running the network, typically doesn't want to touch it because they're not a professional. They're not used to dealing with networking, and once everything is working, they just want to leave it alone. And so what we want to make sure we do is we have a platform that has enough performance to allow us to bring new services to them without them having to touch the device at all, and to be able to make sure that it's fully managed by us from the cloud. This has some huge advantages for us in that we might spend hundreds of dollars getting the device, in terms of marketing and sales, to get the device landed in that small business, and to get them to try out a new service. If that's going to cost, if that's going to require a swap out of the hardware, that is a huge barrier and could result in customer acquisition costs for that new service that could be hundreds more. But if we have a device in there that's scaled and ready to handle more services than just the initial suite of services that may have been sold to the customer, then we have the advantage of being able to give them a free trial. Just if they're interested in some network security capability that they didn't initially get, let's land it, give them a 30-day trial, and let them try it out without having to touch any wires. They're much more likely to do that, and dramatically lowers our cost to expose them to those kinds of services. Really shifts the economics significantly. So in terms of this device, we've sized it to have from 4 to 16 ARM cores, so that gives us the headroom to be able to run a lot more applications. It has the network connectivity with built-in Wi-Fi to support our managed Wi-Fi services, and as well as connectivity to 4G and coming 5G solutions, so that they can have absolute assurance that their broadband is going to work. So complementing that hardware is a software platform that is focused on this set of users. Again, it needs to have a very lightweight orchestration capability, so that we can bring new applications onto the device, but not have to have the device be so loaded with RAM that it gets priced out of what's possible for a small business. And we surveyed quite a few different alternatives for that, and we landed on the ENEA solution, which has a small memory footprint and could facilitate the kinds of architecture that we need, which is loaded with the capability of having virtual machines or containers to bring new services onto the platform, again, with a no-touch kind of interface with the customer. Conversely, if the customer might be part of a food chain or a food services chain store that has an IT department, they want to be able to directly touch the hardware. We want to be able to have that kind of capability as well, and to be able to allocate computing resources. So if they even wanted to develop their own application and land it on the hardware, that's possible as well. So for us, the key to making this platform really work well for us is the notion that rather than having one device that is performing one function for the customer, we want to have one device that can anticipate and perform the full suite of applications that they might be interested in. So as we mentioned earlier, the critical nature of the internet, we think that backup internet connections are going to be basically essential and expected across even the smallest of businesses, because businesses just can't work without, they stop functioning when they can't have access to the internet. Managed Wi-Fi, SD-WAN, firewall, security, all those applications are of interest, and even facility monitoring and other IoT applications. We've seen quite a few small businesses that have particular needs to monitor different devices. So for example, a restaurant being able to monitor its refrigeration systems to make sure that they're working so they don't suffer food spoilage. Having all of that accessible through a single device is a huge advantage for a small business as it grows, to not have to tear up and reconfigure its networking infrastructure every time their needs change. So the platform that Ooma is developing has all of these capabilities in terms of much higher performance and the kind of performance headroom to host a wide variety of software applications, has great network connectivity both for backup wide area networking and connectivity to the kinds of devices that would exist in a typical small business. And a software infrastructure to allow them to run a wide range of different applications, ultimately, for complete business in a box to run all of the full suite of applications that any small business might be interested in needing to run. Even if today they don't even know that they need those kinds of applications, if we can land it on their box and demonstrate that it's useful to them without them having to take a leap of faith and invest in a new device because the device is there ready for them, we think that will increase the amount of consumption of those kinds of applications. So with that, I'll hand it over to Mac.
Thanks, Toby. So some of the software design observations we've made in developing this platform, there's a number of ARM technologies that we're leveraging. First and foremost, ARM Trust Zone is crucial to secure this physical edge device from software tampering. Most of the software that's on this device is our own, but there is some that is licensed from others, and those often require that we can show that we have a tamper-resistant environment to protect their IP as well as our own. It also just allows for security at the edge, so we can guarantee that the software that we installed for a firewall, for example, is the one that we are running. DPDK in this environment is actually critical for us in that not just because that we're looking for high performance packet throughput. Often you see it leveraged, in the 10 gig and up space for doing user level packet processing. But in this case, it's because we want to preserve as much CPU to have available for other applications. All of our devices to this point have done Linux-based kernel networking, but we're finding much higher performance, as everyone else is, through user-level data plane packet processing. And we're also evaluating ARM's KubeEdge platform to extend our Kubernetes environment all the way out to the edge, and also tie in to MQTT for device management. This leverages some of the monitoring applications that were mentioned earlier. So there's a lot of software performance implications in the universal CPE space. So you have to really pay attention to the interaction of the applications, how they interact with the different CPUs and the memory and the cache in a particular environment. And so we've noticed that there's just a lot of CPU-sensitive use cases that we've already encountered on our other platforms. And as we see higher bandwidths and more applications and more advanced firewall applications, we're going to see more of this. In particular, the firewall, as the internet has moved to be more TLS and SSL traffic, there's a need for traffic inspection for security, and this actually requires a lot more CPU plus hardware acceleration for decrypting of the various streams. And along with this, a lot of the newer VPN and SD-WAN protocols are not IPsec based, so the hardware acceleration that has existed in many of the chipsets does not do as well of a job of accelerating many of the newer ciphers that are available. So you have to fall back on a software implementation for these ciphers until chipsets catch up. But we're designing kind of to the chipsets that are available today, and we're not looking to replace this box in a few years. So we're going to need flexibility to adapt to what happens in the cryptography space. And also the general inspection of LAN and VLAN traffic, the amount of traffic that's on the internal network has actually been going up. And for many of the security applications, you actually want to be able to inspect all of this traffic, even if it's not leaving the network. In particular, if you're looking for applications that are trying to move laterally across someone's network from a PC or something that has been plugged in. There's also more of applying AI and behavioral models to security. A lot of the AI to this point has been driven by video analytics at the edge, but there's also, you can apply these same behavioral models to network traffic, so you don't have to just match some sort of signature for some application or from some network activity. You can observe something that's kind of different behavior and then particularly forward that out to some cloud application that may do some more inspection on that particular traffic. Also, there's virtualization and containerization introduces the managed data plane and a lot of processing requirements. So now you not only have a WAN and a LAN, you effectively have a LAN within the box itself with all of these different applications hosted there, be they virtuals or containers. And so that actually adds an additional level of processing that's needed for moving these packets around in a virtual switch or some other approach within the box. And the IoT edge processing, in this particular, we talked earlier about low raw sensors requirements. So there's the sensors themselves, which are relatively low bit rate, but there's also a move to move analytics for these sensors out to the edge of the network. There's various platforms available from various providers that can do that, so that initial processing of the sensor data happens at the edge, and you limit the amount that's uploaded to the cloud. And there's an opportunity here also to apply AI or machine learning to some of these processing. But given that we probably won't have AI accelerators in all of these devices, though that may be an option, we're going to rely on the CPU for doing that processing, and that is also taxing the CPU and memory performance. So lastly, there's a number of firewalling performance challenges like mentioned earlier. So if you look at implementing an advanced firewall, it requires careful design, especially on these 4-core processors as we're adding additional capabilities here. As I said earlier, we aren't necessarily talking about very high packet processing rates because in general, our customers are going to have 1 gig type connectivity at the most. The 5G is kind of introducing some higher burst speeds that we could see there, kind of depending on their applications. But the customers that we talk to are increasingly seeking better protection than just a stateful firewall. So there's beginning to be some, that just a basic NAT-based firewall with some basic stateful inspection isn't really enough given the threats that are out there. So they're often looking for intrusion detection and prevention. So they're looking for network packet flows that are unexpected in their network. And they're also often using some sort of unified threat management, provide some antivirus and malware and web filtering. They probably at this point are also deploying something on their endpoint PC, but they also need something that can kind of just look across the whole network. And especially if they have networks that allow connectivity like to Wi-Fi by customer devices and those kind of things, they're going to want to make sure that that traffic, even if it's on a VLAN, isn't some threat that's there. They don't want that infection to happen through their actual network. And the increasing amount of traffic, as mentioned earlier, that's SSL or TLS, that's just raising the amount of CPU that's needed in order to do the inspection on these flows. And many of our customers, while a lot will have high bandwidth connections, many will not. And they will also won't want to pay for having to backhaul all of that content to the cloud to be inspected. So there's definitely a market for doing that kind of inspection at the edge. And all of these kind of require careful attention to the design decisions as we optimize having multiple applications kind of running in the same device. As you see here, we've got some examples of throughput kind of numbers for various kind of applications. And with that, I'll turn it back over to Chris.
Perfect. Thanks, Mac. Thanks, Toby. Hopefully you get a sense of our excitement around this. This is a bit of the holy grail, if you will, for the small business customers in particular, that there is this concept of a single device that is a flexible platform that allows all the connectivity on the LAN side, the ability to handle multiple different WAN side internet connections, and allow them to cost effectively implement solutions like next generation firewalling and software-defined WAN to handle those multiple connections, facilitate wireless connectivity in that customer's environment, and being able to do all of this in a secure manner. We really see a wonderful opportunity here with this platform to deliver a suite of services, but as you heard from Mac, it requires some really careful design considerations that we've discovered in this process, that it's easy to design a solution for a point function like just next-gen firewall, but it really requires paying close attention to your software architecture and the hardware platform that you're implementing to make sure that you maintain that flexibility to run lots of different applications on this single device. We look forward to any questions that you may have, and thank you for attending our session today.